Okay, on the exam that you're going to have in WebAssign, there are going to be approximately 3 to 4 questions I'm going to ask you to show your work. You will be required to have a testing booklet, and this is the sort of question that I would expect that you can show your work out step by step. Final answer will get you no credit. So let's ask you something like this. To find the derivative for f of x equals the square root of x using our limit definition. So let's jump on that. Okay, I'll do my work in blue. And here's my argument. F prime of x equals the limit as h approaches 0 of the square root of x plus h minus f of x all over h. So I'm using that limit definition where it is the f of x plus h minus f of x over h. Now, obviously, I can't use 0 as a direct substitution, so I'm going to rationalize my numerator by multiplying the top and bottom. Take a look at this. And I'm going to multiply my top and bottom by this. And the idea is I'm using the difference of perfect squares in factored form technique. Now, when I do that, what happens is what I have is a minus b times a plus b gives me a squared minus b squared. So if this first object is a squared is, and again if the second object is b, so it's going to be a squared minus b squared, so the square root of x squared is just x. All over h, and I'm going to leave the bottom alone because it cannot be simplified. However, I have a positive x and a negative x. These two eliminate each other. As h approaches 0 of h all over h times the square root of x plus h plus the square root of x. Notice, I now have a fraction that is reducible. And so I shall reduce it, and it's giving me a new object that is exactly like the old object, except for possibly at h equals 0. This object, however, I can analyze because I can plug in h directly. And again, remember, I am looking for the derivative of the function at x, and now I'm going to go ahead and plug in 0 for h. And when I do that, I end up with the square root of x plus 0 plus the square root of x, which simplifies into this object looks exactly like that object. So one object plus another object is two of those objects. And that is my final answer. So I was able to find the derivative of this function using the limit definition. I'm going to do one more for you. So we're going to find f prime of x, the derivative, given f of x equals 1 over x. And again, I'm going to use my limit definition to find this. So, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now in this situation, I cannot plug in 0 because I would have 0 in a denominator which is undefined. But what I'm going to do is take my two fractions on top and add them together by finding a lowest common denominator. Now they both have denominators that are different and have nothing in common, which means my LCD will actually be the product of the two. So that is my lowest common denominator, and I need to make both fractions have that. First fraction, 1 over x plus h. I get the x by multiplying the top and bottom by the same thing, and now I have the LCD. Minus 1 over x. Again, whatever I do to the bottom with the fraction, I must also multiply to the top. So to get the LCD, I need to multiply by x plus h, and I will do that on the top as well. Still both fractions over h. Now, so I have on top a fraction with addition and subtraction going on, and since they have the same denominator, all the addition and subtraction happens in the numerator. So this is still the top all over the bottom, which is still h. And my top now is x from the first minus this, just distributed my negative to each subterm. Notice I have a positive and negative x. They eliminate each other. So one thing I'm going to do is represent that elimination. Giving me negative h over x plus h times x, and I'm going to divide it all by h, but since I'm dealing with fractions, instead of dividing, I can also call that multiplication by the reciprocal. Very important property we have in fractions. This gives me two fractions whose product is reducible because I have an h on top and an h on bottom. And this will leave me a new object that is exactly the same as the old object, except for possibly at h equals 0. Now I have an object where I can use direct substitution by plugging in 0 for the h to get my limit. And I end up with negative 1 over, when I plug in 0 for here, x plus 0 is x, times x, which is simply negative 1 over x squared, is the derivative of 1 over x. So again, limit definition, simplifying this step by step on this object. This is the kind of thing I'm going to expect to see on your exam. So if you're not prepared to show me this on the exam, need to make sure that you're practicing. Be happy to work with you on video conferencing using Skype or Zoom. Just give me a call, and I'm happy to see your process anytime.